Okay, yesterday we did everything from one-step, two-step, and multi-step equations, right? But everything that happened yesterday, the variables were all on the same side of the equal sign, right? So today it's going to be different in that all of our variables are going to be on opposite sides of the equal sign. So I have you a little hint right there, and I have it highlighted. So if you don't have any distributive property or any combining like terms to do, what we want to do if we have variables on two different sides of the equal sign is get them together first. And we're going to use our inverse operations just like we did yesterday. Okay? So let's get our C's together. So we could do two things. We could subtract 20C from 5C on both sides, or we could subtract 5C on both sides, right? Can somebody tell me what you would prefer to do?
5C.
Subtract the 5C. Why would you prefer to subtract 5C?
Smaller number.
Yeah, so you'd have a positive, right? I typically like to go for having positives myself. And sometimes it actually makes it a little bit less difficult. So I'm going to do it this way. If you subtract 20C from both sides, that is not incorrect. You still will get the correct answer if you do everything else correctly. So what is 20C minus 5C? 15C plus 5 equals 65. And now we just have one variable now, and that was the whole point in getting your variables together. And now it looks like a two-step equation from yesterday. So now what do we need to do to get C by itself? Subtract 5 on each side. So 15C equals what? 60. And then what do we do? Divide by 15 on each side. And C equals 4. So any questions on how we got C equals 4 from that? So get your variables together first and then solve it like we did yesterday. So on problem B there, go ahead and copy that down if you haven't already. We have two different P's on different sides of the equal sign. So somebody tell me how we want to get our P's together. There's two different things you can tell me.
Subtract 8P from both sides.
Was that what you were going to say, Sydney? Okay, good. Subtract 8P on each side. And if I do that, I'm left with negative 2 plus what? 2P equals negative 1. And then we're going to get everything away from the P. So what do we do now? Add 2 to both sides. And so I have 2P equals 1. And then I do what? And what do we get? P equals what? A half. So any questions about how we did that and got P equals a half? Okay. This next one, problem C right here, it looks a little different because it doesn't have an extra term on the end. But it still has an M on each side of the equal sign, right? So to get our M's together, we could do one of two things. We could subtract 24M on both sides. But if we subtract the 24M, what happens? You'll be a negative. And also, what happens after the equal sign, though?
Nothing.
There's nothing there to use. So we'd have to put a 0 there, and that's actually going to give us more steps. So if we have a variable hanging out by itself on one side of the equal sign, bring everything else to that variable. Does that make sense? So how are we going to bring the 11M to the 24M? Subtract it. And so 26 equals, what is 24M minus 11M? 13M. How do we solve for M now? And what is 26 divided by 13? 2. So any questions on how we do one like that? So if you have a variable by itself, bring everything to that side. All right, you guys are going to try these two on your own, on your paper. right, when you finish both of them, go ahead and share with a neighbor. If you're still working, keep on working. All right, you guys, I want everybody, all 24 of you, to tell me what you did first on number 1. Add 3m to both sides, right? And that got you 24 equals what? 8m. And then what did you do to solve for m? And I'll be honest, when I worked that first block, I missed it because I subtracted 3m over here. And I got 12 for my answer. But that's a common mistake. People do that, right? They'll add on one side and subtract on the other. So it's okay. I hadn't had enough coffee at that point. So raise your hand if you got 3 equals m for number 1. All right, good job. Number 2. What do we want to do first on number 2? Yeah, you can subtract n to get your n's together, or you can subtract your 4n, right? And since I like positive numbers a little bit better, I'm going to subtract n. And that would get me 20 equals what? 3n minus 7. And like I said, if you did it another way, it's not wrong. Don't erase it. And then what do we do? And what do we get? 9. Raise your hand if you got 9 for number 2. Are there any questions about how we solve these kinds of equations? Okay. Next, we're going to do them with parentheses. So go ahead and copy down problem D, please. So what do you think we're going to do first on problem D here? Distribute. Very good. Now, let's just talk about fractions for a second. Multiplying by 1/4 is the same thing as also doing what? Dividing by 4, right? So if these numbers are divisible by 4, and I think they are, it should be pretty easy. So we're going to copy that 9x minus 5. And so what is 1/4 times 16x? Yeah, you just divide by 4 and you get 4x. Very good. Bless you. And what is 1/4 times 60? 15. So is everybody okay with us distributing that 1/4? Pretty easy. All right, so now what do we want to do to get our x's together? Uh-huh. And what is 9x minus 4x? 5x. Equals 15. And then what? Yep. So 5x equals 20. And then divide by 5 and x equals 4. So that wasn't so bad, was it? We're just continually adding a few things as we go. So look at E. Write that down if you haven't already copied problem E. What's going on with problem E? We got to distribute on both sides, don't we? Okay, so the left side shouldn't give us any problem. What is 4 times 2r? 8r, which sounds funny when you say it. And what is 4 times negative 8? Okay. And using the same thing we did a while ago, what's 1/7 times 49r? 7r, good. And what's 1/7 times 70? 10. All right, any questions on distributing that? All right, let's get our r's together. What do we want to do? Yeah, and this is going to make it very easy for us because what is 8r minus 7r? 1r, which I can just say is r, and that will save us a step. And then lastly, we can do what?
Add 32.
Add 32 and R equals 42. Any questions about those? What you have to distribute? All right, next I think I have a couple of you tries for us. And I want y'all to try that fraction on number 2 and do it whichever way you do it, and then I will show you my trick. But I want to see if y'all can get it right without my trick. All right, I see a lot of pencils down. So if you're finished, go ahead and check with a neighbor. If you're not, keep on working.
That's what I got.
Did you say negative 18 over 2?
No, I got negative 18, and the other one I got 2.
Oh, I thought you said if it's negative 18 over 2, that's 9. But negative 9.
I don't know what happened.
Let's see. I'm hearing a lot of different answers, so let's work these. I'm getting curious here. All right, so number 1, what did we have to do first, guys? Distribute the 5 on the second side, okay? So I'm going to copy the 3 minus 4a equals what? minus 15. And then somebody tell me what you did to get your A's together. Yeah, I would add 4. If you subtracted 5A, that is also fine. Yeah, if you didn't do it right, fix it. Now what do we need to do to get A by itself? Add 15 to both sides. And what is 3 plus 15? Equals 9A. Divide by 9. And A, it looks like a Q. And A equals what? Raise your hand if you got 2 for number 1. Are there any questions about it? Does everybody understand why it's 2? All right. So what do we have to do first on number 2? Distribute. So I'm going to keep my 8y minus 6. And I'm going to distribute 2/3. Now, technically, you can come over to the side and say 2/3 times 6 over 1. Correct? Right? And so that would be 12 divided by 3, which is 4. So that would be 4y. Right? Right? My little shortcut that I do, I just basically do it in my head. I say top number, numerator, times the big number, divided by the denominator. So top times big divided by the bottom. 2 times 6 is 12, divided by 3 is what? 4. That's how I do it in my head. But it makes the same thing as this because you're leaving out the 1. Right?
Will that work every time?
Yeah. It will. And then you simplify it as a fraction, not a whole number. Does that make sense? Top times big divided by the bottom? Because it's the same thing as putting a 1 over this and multiplying across. You're just leaving out the step with the 1. Does that make sense? So that's 4y. So let's try my trick over here. What's 2 times 15?
30.
Divided by 3 is what?
10.
Did y'all get 10 for that piece? So there you go. I shared my brain with y'all. You're welcome. Add that to your knowledge. All right. So then I would probably get my y's together. Subtract y, 4y. What's 8y minus 4y? Equals 10. And then what? And then so 4y equals, divide by 4. And y equals 4. Raise your hand if you got y equals 4. Some way, somehow. Different than mine is okay. Okay. Did my way of multiplying that fraction and whole number, did that make sense to y'all? I mean, if not, you can always come over to the side and do this thing. Okay? So, and whatever just works for you, as long as you can do it and keep it mathematically correct, I'm good with it. All right. The last thing we're going to do in this lesson. Yeah. The last little twist. It says, solve the equation if possible. That means it's possible, but that the equation is impossible to solve. Possibly. Right? That means the equation is possibly impossible to possibly solve.
Yes.
Yes. Let's overuse that word a little bit, right? So if it is possible, that means it's like normal. We get x equals 2 or y equals negative 15, right? We get a variable equals a number. So if an equation is possible to solve, it's normal. We get variable equals a number, right? So, but there are cases where equations are impossible to solve. So we're going to see those. So copy down problem F, if you haven't already, 3x equals 3 parentheses x plus 4. Now, we're going to treat it like it's possible, right? So we just start working it. So what will we do to work out problem F here? We're going to distribute. And we're going to get 3x equals 3x plus 12. Right? Then what will we do? Subtract 3x to get our x's together. And then magic happens. Right? What magic happens?
Everything cancels out.
All the x's disappear, right? They cancel out. They make zeros. So we can't really leave nothing on the side of an equation, so we're going to have 0 over there equals 0 plus 12 is 12. Y'all see how that happened? The variables canceled out because once I did the inverse operation on both sides, I made zeros. But does 0 equal 12?
No.
No. So if you have a false statement left over after variables cancel out, you're going to get no solution. Now, what does that mean? That means there is no such number for x that would make that equation true. There is no number that we could use for x that would make that a true equation. That equation is impossible to solve. You get no solution whatsoever. There's no x in the world that will make that a true equation. Does that make sense? No numbers fit that. So your variables have to cancel out, and you have to show me this. You have to show me that two things are equal to each other that really don't equal to each other, and then you can tell me no solution. You can't just look at a problem and be like, no solution. Okay? You've got to solve it down to that, cancel out your variables, and tell me the final statement. Like, I want to see this part. Okay? And then tell me it's no solution. Because it might not be no solution. Something else could happen. So let's go to problem G. So we treat it like it is possible to solve it. So if I'm just assuming it is possible to solve it, how would I solve problem G? I'm distributing. So 2x plus 10 equals what? 2x plus 10. And then we'd get our variables together. So what would we do to get our variables together? Subtract 2x on both sides, and what happens? They cancel each other out. Now, what am I left on each side of the equal sign? 10 equals 10. Does 10 equal 10?
Yes.
Yes. That is true. So you see the difference? On the first example, it was false. On the second example, it's true. So if you're left with two numbers that are the same, they are equal to each other, you're going to say all real numbers. So if it's true, you say all real numbers. Now, what do you think that means? Yeah, it means I can use any number in the world for x, and it's going to be true on both sides, right? For example, if I use the number 2. 2 times 2 is 4 plus 10 is 14. This side makes 14. Okay? 2 plus 5 is 7 times 2 is 14. This side makes 14. Right? And 14 equals 14. Any number I could come up with to use for x would make it a true statement. So that's what all real numbers means. Every number makes that true. Okay? So if you get your variables cancel out and it's false, you say no solution. If your variables cancel out and it's true, you say all real numbers. If your variables don't cancel out, you just solve it. Okay? Y'all try these three and see what happens. And that first one is supposed to be number 1. It kind of went off my screen a little bit. So 3 different problems. I want y'all to solve them and see what happens. If you have trouble reading something, let me know. I'll call it out. see pencils down everywhere. So if you're still working, keep working. If not, go ahead and check your answers with a partner or a couple of them. All right, y'all ready to help me out so we can get done? All right, number one, what did you do first? We distributed first. Okay, so I got 9x plus 12 equals what? Plus what?
27.
27. And then we got our x's together by subtracting 9x from both sides. And what happened? They canceled out. And what was I left with? Is that true? No, it's false. So if it's a false statement left with my equation, what do I say? No solution. Raise your hand if I can spell solution. Raise your hand if you got no solution. Very good. Now raise your hand if you did number 2 and thought you got it wrong. Be honest. If you got your answer number 2 and you thought you got it wrong, what did we get for the answer on number 2?
0 equals W.
We got W equals 0 or 0 equals W, right? Y'all, sometimes people freak out because they get 0 for an answer and think it can't be 0, right? 0 is just a number, y'all. Okay, it means nothing, the absence of number. Okay, but it is a number. It's legit integer. So sometimes we get 0 for an answer and think that can't be right. But if we get negative 20 over 7, that looks right, but 0 doesn't. But whatever. But if you get 0 for an answer, it's okay. So we subtracted 7W, right? And we got 1 equals W plus 1. And we subtracted that 1, and 1 minus 1 equals 0. So yeah, if you got 0 equals W, you are correct. So raise your hand if you got that correct. So was it possible to solve this one? Yes, it was. If we get variable equals a number, it is possible, and we just solve it like normal, okay? Actually, the no solutions in the all real numbers, they're special. They rarely happen, okay? They're not the norm. The norm is to get variable equals a number. Does that make sense? All right, and number 3, what do we do first on number 3? What do we get on the left-hand side?
6A plus 6.
And what do we get on the right-hand side? All right, so it already looks like it's going to be the same on both sides, right? So we subtract 6A, cancel, 6 equals 6. True or false? So what do we say? All real numbers. Raise your hand if you got all real numbers. Any questions about these at all? Any questions about anything about the lesson? Okay. Bear with me for a second.